So on this problem, they're telling us angle B is 16.5 degrees. So this is 16.5 degrees right there, like that. Good. And then we're going to try to find this angle. We know all three angles total 180 in a triangle, right? So this one's already 90. So if I take, 90 and 16.5 and I add them up, what's that going to be? 106.5. And then I subtract from 180. I get something, 73.5 degrees. So angle A right there is 73.5 degrees. Good so far? Just total 180. Every triangle has 180 degrees total. And okay, so next they want us to find the little a. So I'll put angle big A, 73.5 degrees right there. Okay, now they want me to find the little a over here. How do you do it? Well, there's a couple of ways. You could use the 73.5 and the little a. What else do we know? Do we know anything else? Oh, the b. The b is down here is 36.5. They gave me that. Okay. So anyway, yeah. So if I want to find little a here, then I want some relationship involving the little a and the 36.5, right? I don't want to use the little c because I don't know that. I don't want two things. I can't have an equation. I can't solve an equation that has two things I don't know. Am I making any sense? So you want to set up some kind of trig relationship, sine, cosine, or tangent. The whole SOHCAHTOA thing. So that you basically use this guy and the little a. Does that make it? Do you see why I'm doing those two? Because they're asking me for little a right now, so I certainly got to have him in there. And then I'm going to use the 36.5 because that's the side I know. And then either one, you could use this angle, or you could use this angle. It doesn't really matter. Really, either one's fine. So let's say I just use the 73.5. So 73.5 is what over what? This for 73.5, this is the opposite, this is the hypotenuse, this is the adjacent to 73.5 anyway. Now you could use the 16.5 instead, and that'd work fine too. So I'm going to use this one. So that's tangent, isn't it? Tangent of 73.5 is the little a over 36.5. Everybody see how I came up with that? Because tangent is opposite over adjacent. Tangent's opposite over adjacent. So for 73.5, tangent is opposite over adjacent. That little equation. Now I want to solve for little a. So what do I do to solve that equation for little a? Multiply by 36. You always multiply by the denominator, huh? Whatever's in the denominator, both sides. Little a equals. Somebody got an answer there? Rounded to two places, hundredths. 2 zeros, two places. 123.22. Is that good? Other people getting that? That's good. Okay. So we've got verification. So there we go. There's the little a. Is that okay? Questions I can answer on that? Is that making sense? Okay. So now let's find the little c. So to find the little c, which is right here, I want to use this side. I really don't want to use this 123.22, even though, yeah, we know this other side now is 123.22. It's a rounded number, huh? It's not exactly 123.22. So you'd be better off not to use it, because it's not, or if you want to use it, to use more decimal places. So I'm just not going to use it. I'm just going to say, look, I don't need it. I can use this, the 36.5, which is exact. 36.5, that's exactly what it is. They gave it to me precisely. And the 73.5 and the c. So that would be adjacent over hypotenuse, wouldn't it? Which is cosine. So I could do cosine. There's other things I could do. I could do cosine of 73.5 degrees is adjacent 36.5 over hypotenuse, which is the little c. That's one thing I could do. You could go up to the 16.5 and do sine, right? You could write sine of 16.5, sine is opposite over hypotenuse, that would be 36.5 would be the opposite side from him over the hypotenuse C. That'd be fine. Make sense? Either one is good. So just somehow, see how my thinking was. Somehow I thought I've got to get the 36.5 and the C in some kind of trig function. And so depending on what angle you start with, if you start with the 73.5, that's adjacent over hypotenuse, so cosine. If you start with the 16.5, you can do that instead, then that's opposite, right? From the 16.5, that's the opposite over the hypotenuse from his perspective. Right? Doesn't matter. Either one will work fine. The answers will all come out the same. So how do I solve this equation now? What do we always do? We multiply by the denominator. Even if the denominator is a letter, it's still the same game plan. If the denominator is a number or if the denominator is a letter, either way, same action is required. Multiply both sides, get this out of the way there, by that, and then it cancels, huh? We good there, and you get C times the cosine of 73.5 degrees equals 36.5. Good to there? And now how do we solve for C? Just divide by that cosine of 73.5 degrees. Like that. Boom. C equals, somebody got it? Anybody? 128.51. That good? Other people getting that? Yep. All right. There it is. 128.51. Is that okay then? On that? Questions I can answer on that? All is well? All right. Let's do that. Okay. So, because this one's a little different. This one will be a little different than 1 and 2. So they're giving me little a is 12.2. They're giving me little b is 24.8. Okay. And the first thing they want over here is they want little c. How do we find little c? How do we find the other side? So what am I going to do to find that other side? Pythagorean. A squared plus b squared is c squared, huh? Yeah. So Pythagorean theorem. A squared plus b squared, right? Because that's true for any right triangle. You guys with me on that? Any right triangle. Any right triangle, you can do a squared plus b squared equals c squared. So, what's that going to be? This side squared plus that side squared, so 12.2 squared. Let's do that. 12.2 squared plus 24.8 squared is c squared. Is that good on that? And then crank that out. On that, maybe so I'm going to grab my calculator. So go ahead and crank that out. I'll grab my calculator down the hall here. Alright, you guys getting that? So 12.2 squared plus 24.8 squared. So this side comes out, I'm getting 763.88. We still have to root it. Equals c squared. Getting that on that side, and then we square root both sides. So square root. So, where my square root button is. There it is. Yeah. Square root. You ever use the answer button on the calculator? Kind of helpful, right? You know how to use that. So I'm just hitting square root of the answer. So you have an answer button in the lower You guys want to do that in the lower part of the screen there? Right? So, just make things easier. You want to make life with the calculator easier. Yeah, so I just did the first guy, 12.2 squared plus 24.8 squared, hit equals, got that 763.88. And then I just hit square root of answer. My answer button is, at least on the TI, I mean, it's different place every calculator, but you can't hardly see it. But this is answer down. It says above it, it says A and S, answer button down here. So you almost all the calculators have those down. It just means the answer from the previous line. So I just take the square root of the answer from the previous line. And it's real nice, real useful button. Square root of the answer from the previous line is 27. That way you don't have to write it down, type it in again, or something like that. Just square root of the previous answer. And I'm getting C equals, whatever that says, 27. How many places they want? 100. So 27.638 will round to 27.64 for C. We good? So there's C, but that's not all they're going to ask for. 27.64. Good so far? So good to, oh, I'm not even showing you anything. So there we go. So is that good to there so far? Questions to that point? Is that good on C? So now they're going to ask me for the angles. So how they're going to ask me for angle A here. So how am I going to get angle A next? How am I going to do that? Yeah. Everybody see that? So you can do tangent. It's a really good idea. So tangent of angle A. Remember tangent, SOHCAHTOA. Tangent is opposite over adjacent, right? So the opposite over, right, this is the opposite and this is the adjacent, it's the hypotenuse. So opposite would be 12.2 over 24.8. Does that make sense there? The tangent of A is opposite over adjacent. 12.2 over 24.8. And so then what is that? 12.2, whoops. 12.2 over 24.8. I'm getting, move this out of the way, getting tangent A is 0.49193548, it goes on and on. 354839. Anyway, so we're getting that. Now, that's the tangent of A. That's not A itself. How do I get A itself? Inverse tangent. Inverse tangent. Do you see that? We doing okay with that? Let me write that down right here. So that means A itself is inverse tangent of that 0.49193548 thing. And make sure your mode is degrees. Mine is not right now, so degrees. And I'm just going to hit inverse tangent of that answer. And I'm getting capital A is 26. I don't know how far they want me to round. I'll say 19 degrees. 26.19 degrees. So everybody see how I did that? Let me stop and slow down there because I know that's the tricky part. Let me help with that. Right? So going up here again, tangent is opposite over adjacent. So I did right up here, opposite over adjacent, 12.2 over 24.8. Divided them on my calculator, so I had tangent A is that 0.49 blah, blah, blah number. So therefore, A is the inverse tangent of that. That's how you find an angle inside of a tangent or cosine or whatever. You do the inverse. Because remember what inverse does? Reverses inputs and outputs, doesn't it? Remember how we talked about that, right? So A is the inverse tangent of that. If the tangent of the angle A is 0.49 whatever, then A is the inverse tangent of that 0.49. A is the angle. Is that good? Right? Because remember how trig functions work, inverse trig functions work. Normal tangent, you put in an angle, you get out an answer, right? So inverse tangent, remember we talked about inverse function, switch in like an inverse toaster? You put in toast, get back bread, it reverses inputs, outputs. Did we talk about that? So for an inverse tangent, you put in an answer, you get out an angle. And that's what I did. I put in the answer to inverse tangent, and what I got out is the angle, which is what I wanted. I wanted the angle. How are we doing on that? We good? So then we have angle A, and once we have angle A, what is this, 26.19 degrees? We can easily get the other angle because of the 180 total, huh? The three angles total 180. So then you just subtract from 180, you can get the other angle, and then that's everything. Is that good on that? Questions I can answer on doing that? All right, so that kind's a little harder. So did you notice we had two kind of triangles? We had like number 1 and 2, we did number 2. So number 2, they gave you an angle, or the 16.5, they gave you one of the angles. If they give you one of the angles, that's easier, because then you can find the third angle, because the 180 total, and then the sides come easy. If they, on number 3, they did not give us any angles, they just gave us the two sides, and so how we did the angle ended up being inverse tangent. And that's what you always have to do. When you don't have any angles, and you only have sides, you're going to have to do some kind of an inverse trig function, sine, cosine, or tangent, depending on which sides they gave you, in order to find the angle. Question?
You said to find B, subtract 180 from 26.19 there.
Well, and the 90. Yeah. So I could do it real quick. So to find, so you would take this one's 90. So you would take 90 and 26.19, add those up. What's that going to be? 116, and then subtract that from 180. Take 180 minus the 116.19, because they told me, what is that? I don't know. 63.81. I think that's the other angle. Angle B. Like that. Yeah. Good? On that? All right. We'll move on. North, south, east, west, and degrees and bearings. So, okay. So suppose, I guess a couple questions on that. Suppose you have something that's headed off. Let me make it a little bigger here. What if you have something that's headed off this way, 61 degrees. This is north and south and east and west. So how do you say that heading, that bearing? Well, the formal way that bearings, headings are listed is you say north or south first. So let me write that. So for a bearing, you say north or south first. Well, let me put the first. So you first say north or south. In other words, not east or west. You first say, hey, it's north, then say the degrees, then let me put say, then degrees to the right, it would be east, or left, well, that's not true, never mind on that, then degrees east or west from the north or south, from the vertical. That's a good way to put it. From the vertical. In other words, let me just maybe define a set it would be helpful. So the way you would say this bearing is you would say, look, the plane, the ship, whatever is headed north, because it's headed more north than south, right? So you first say north or south. Certainly not headed south, is it? It's headed this way, truly. How do you say it? You say, well, it's headed north, but not straight north. How many degrees off of the vertical? So it's exactly the opposite of reference angles. Remember, reference angles, we always go off the x-axis. For bearings, you go off the y-axis. That's just how they made it. You know, there's no reason for that. That's just common usage over the years. That's how people have listed bearings. So you'd say north, and then how many degrees is this right here? Yeah, because it's 90 minus 61, right? Because 90 degrees total would be 29 degrees. So you would say, so the answer would be north, 29. Now that 29 degrees is towards what? The east or the west? Well, east. That's the answer. North, 29 degrees east. That's how you would say that, bearing. Is that making sense? So you say north or south first, and then the degrees off of the vertical. Exactly the opposite of reference angles. Reference angles are always off the horizontal, aren't they? This is just how they made it up. They could have done it some other way, you know. But they just said, let's make north and south the main one. Whatever reason, they did. So it's north, 29 degrees east. That's how that bearing would be listed for a plane or a ship. So you always say north or south first, and then however many degrees off of the vertical. So north, 20. So that's what they want you to type in here. North, 29 degrees east. That's exactly what Math Excel wants. East. Questions? Is that good? Shall we try another one? So number 5, try that one. Let me give you a second. See if you can list that heading. Where's that ship headed? So when you first say north or south, even though that thing's mostly headed west, isn't it? You still have to first say north or south. That's just how the lingo goes. So first say north or south. So which one is it? More north or more south? It's more south. South, so it's headed south. So I always kind of think this way in my mind. It's headed south, but not directly south. So then how much off of the vertical? Well, the 80. Yeah. 80 degrees west. South 80 degrees west. Is that working? Is that making sense?
You always go the number off the angle
off the vertical. Yeah, because you said the vertical first. You're always saying north or south first, so you're always specifying the vertical first, and then how much off that vertical. Yeah, so it's exactly the opposite of reference angles, huh? Reference angles are always off the horizontal, aren't they? Why? Because that's where we start. 0 degrees is where they picked to start all angles. Horizontal. That's just what they picked. Here, bearings, they just always pick north and south first. Just what they picked. So then our degrees comes off of that. So it's south, but it's 80 degrees west of south. So here's the actual direction the ship is headed. It's south, but 80 degrees west of south.
How come from the north one you have to subtract it from 90?
Yeah, good question. Yeah, this one we just did 80, but like we didn't subtract from 90 this time. Yeah, because if you look back on this one, the 61 they gave us was off the horizontal. See that? And these are always off the vertical. It's always off the y-axis. So here's the y. So I need this angle, don't I? Does that make sense? So that's why I had to subtract from 90. Does everybody see that? So on this one, the angle they gave me was off the x. That's not the one I want. I want the one from the y. See, whereas in this one, they gave me the one. This is the one off the y, so I didn't need to subtract. Everybody see that? It was already given the right way on this one, off the y. You always have to give them the angle off the vertical on that. Okay, so this is question number 6. And it says, we got some formula here. So distance equals 7 cosine pi over 2t. T is measured in seconds, is what kind of goes off the screen there. T is in seconds. D is distance. D is distance in inches. Now, what is this a formula for? Well, this is something, an object moves in simple harmonic motion. What is simple harmonic? If you go on in physics especially, and chemistry as well, harmonic motion is anything that's, well, like a sine and a cosine is harmonic motion. Let me just give you, for example, how about a clock? You know, with the little arm, a manual clock that just, what's that called? Like a big grandfather clock or something like that.
Pendulum.
Pendulum, yeah, it's a pendulum. That's totally what it is. Yeah, that just swings back and forth. You know, just swings back and forth. Right, just sways back and forth, back and forth. That, how would you represent, like, anything that goes back and forth can be represented with trig functions. That's what they are. Remember, trig is made up. We're learning all these trig rules and everything. But remember what trig is? Totally made up. All of math is made up. to describe things that are real. So when they run into real things in the real world, they go up and down, back and forth, back and forth. The current coming out of the wall, the alternating current goes high and low, high and low. That's why it's alternating. 120 AC means alternating, up and down, up and down. Batteries are direct current, they're steady. Anyway, different. So all the planets that move, the sun, the tide wave, tons of things in life go up and down, back and forth, back and forth. What do they do when scientists need an equation to represent that thing? They do trig. That's what trig's for. It's sine, cosine. They basically something that goes up and down, up and down, up and down. That's all they are. Seems so simple when you put it that way, huh? That's it. That's all trig is. Made up stuff to represent things in the real world that go up and down, up and down. So suppose you have a pendulum, or like a grandfather clock, and it's just going tick-tock, and just swinging back and forth. And for whatever reason, you need to know exactly where that thing's at. D is the displacement, which is a physics word for distance from the original state. So if the original state is the middle, the steady state, or if you let it settle, the middle, right, then D is the distance it is from the middle at any given time, t seconds, right? So at first, the thing, is further and further and further away, then it's, the distance grows, and then the distance gets smaller, 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 0, and then it's negative, and then back to 0, right? You understand what I'm saying? So the distance, this distance here, well, we would say the distance of the bottom part. Say this, you'd call one side positive, one side negative. It doesn't really matter which is which. So let's say it goes plus 7 inches this way, and then it comes back to 0. This is d equals 0 position, and then it comes back over here to d equals negative 7. Like that, just swings back and forth, right? From 7 inches to the right of middle, to 0 right on middle, to 7 inches left of middle, to back. It just keeps going back and forth, doesn't it? Distance from, displacement from the middle, the original starting point. So what's going to represent that? Sine function, cosine function. What does cosine do? Cosine goes up and down, right? Maximum, right? This is an amplitude. You guys know how to graph these now, right? It's a cosine function with amplitude 7. Starts at 7, goes down to negative 7. Just like the displacement of this pendulum is, starts 7 away, goes to 0, negative 7, back to 0, back to 7, right? On this graph, you start at 7, whoops, go down to 0. The D would be the vertical axis here, and the time would be the horizontal axis. See how they take real life and they represent it with trig? So this cosine function, which I'm graphing here, the distance would start at 0. That's distance 0. At time 0, I'm sorry. At time 0, the distance would start at 7. Right, this is the point, over 0, up 7. At time 0, distance is 7. I keep saying it wrong. Time 0, distance is 7. And then that point would come on down here. Here the height, the distance is the height, is 0. That's when it's back here in the middle, huh? See the correspondence between the graph and what's happened in the real world? Right here, this point is that point. It's positive 7. The pendulum is 7 to the right of the lowest position. And then right here, this is that. That's when it's distance 0. Then here, negative 7, that's that. And then here it goes back to 0 again. Back to there. Here it goes back to positive 7 again. And it just keeps going through its cycle. 0, negative 7, 0, positive 7, right? It just keeps going through its cycle. So that cosine graph represents the real life activity of that pendulum. So if we use this equation, we can plug in any time we want. This kind of thing physics does all the time. Plug in any time you want, and you'll know exactly where that pendulum is. That's how physicists do their thing. That's how they know where things are going in motion. That's how they're able to launch missiles and satellites and know about the orbits of all the planets and exactly where it's going to hit and what it's going to do. They're not guessing. They're calculating. I mean, I know you know they're not guessing, but these are the equations they're using. They're calculating all these kinds of equations. So at any time, any point in time t, we could plug in and we could find out where the pendulum's at, what the distance is. Okay, with all that said, let's go through the questions. Maximum displacement. Displacement is d. D is displacement. What's the maximum d? Well, 7, huh? That's the most it is away. That's it. They're basically asking amplitude, though. Now you might say, what about negative 7? Remember how amplitude, we always just give positive? It's just like distance. What if I said, what's the furthest point away? You know, I don't give negative, we don't give negative answers to distance, do we? Just by common agreement. Same thing with displacement. They just always give the positive answer. All right, now, next question, frequency. Now, what's frequency? That is upside down of period. So let me write that out for you. We haven't talked about that. It's new. So you remember the formula for period? Let's just do that. Period is 2 pi over b. You're going to have that in your 3x5 card for the test next week, right? 2 pi over b. Well, frequency is exactly the upside down. It's b over 2 pi. So frequency and period are exactly upside down of each other. That's all it is. So, let me come up here where we have a little more room. So what do I mean by the b? You guys know what the b is in the basic sine or cosine? Remember, a is whatever's in the front here, and b is whatever's next to the x or the t or whatever your variable is, right? And c, if there was a number added, but anyway, we don't have a c. So a is the number in the front, b is the number right next to the x or the t or the theta or whatever is your variable. So the b is pi over 2. So the frequency then is going to be b pi over 2 over 2 pi. Makes sense? B over 2 pi. And what do we always do? Yeah, how do we do that? Well, this is, there's a couple, you could say this is 2 pi over 1 if you wanted, and then flip that up. So this is pi over 2 times 1 over 2 pi. Am I confusing you? Let me slow down there a bit. So, it's b, which is pi over 2, over 2 pi. But remember when we have a fraction over a fraction, what we always do is we grab the one on the bottom and we flip it up to the top, and which is a little weird when it's a 2 pi. You're like, it's just 2 pi. It's not a fraction. Well, it's 2 pi over 1. If you need to see it as a fraction, then it's 2 pi over 1, huh? So flip it up, it becomes 1 over 2 pi. We good? So we always do with a fraction on the bottom, flip it up. And then these pi's will cancel. And it's 1/4, isn't it? 2 times 2? 1/4. That's 1/4 cycles per second. What that means is it does 1/4 of its full cycle every second. 1/4. What's its full cycle? Well, full cycle, like for cosine, remember cosine? It'd start at high, start here, go down and back up, and finish high again. That which means go back there and back here again. That'd be 1 full cycle. Pendulum starts out here, goes back all the way left, and then all the way right again. That's 1 full cycle. That's its whole story. It just keeps doing that whole story, right? That's a cycle. That's a period. That makes sense? So we're saying it does 1/4 of that cycle every second. So it does what would 1/4 of that be? I guess it would just be just straight down, huh? Because there's down, left, down, and right again. So 1/4 would just be down. So it only goes down 1/4 of its cycle in 1 second. So it goes 1 second, 1 second, 1 second, 1 second, is I guess what it's doing. Does that make sense? 1/4 of a cycle every second. And then the period, which is it says the time required for 1 cycle. That's fancy talk for period. The time required for 1 cycle. Do you realize that means period? That's what period is. How long for 1 cycle? So you can write that in your 3x5 card if you want to help yourself out. Time required for, how long for it to complete 1 cycle? That's what we call the period. How long for 1 cycle? How long for 1 cycle? Well, that's just upside down. You can just grab this number and flip it. Period, 4. 4 over 1, 4. You see that over there? Yeah, 4. The period is 4, which is what I got there. Meaning 4 seconds. Right? If it does 1/4 of its cycle every second, then it does its whole cycle in 4 seconds. That makes sense. Right? 4 seconds, it completes its whole cycle. So it starts out 7 to the right, goes down, left, down, right again, does that whole thing in 4 seconds. Does its whole cycle every 4 seconds. It does this from here to there and back. And so this would be 4 seconds. If they wanted to graph it or something, that means on the x-axis, this would be from 0 to 4 seconds. It finishes its whole cycle. Then it just keeps repeating that every 4 seconds. Is that all making sense? I like to tie the real world into these equations every now and then. I think it can kind of help. Good? If you like this stuff, take physics. Physics is very challenging. Physics is the hardest thing. I have great respect for physicists. It's like math with all word problems. That's what it is. Physics was the hardest thing I did at junior college before I transferred. Physics, for sure, was the hardest thing. Very challenging. All right. Well, so we've got D. Here, I'll write it up here. D equals 1/3 sine of 2t. You don't need the parentheses anyway. So sine 2t. Same kind of thing. It's some kind of pendulum. What does it mean that they're doing sine instead of cosine? What does that mean about this pendulum? You know, it's going to, 1/3 is its maximum displacement. So this is a pendulum that's not moving very far. This is a tight little pendulum. It's just going 1/3 of an inch. It's like, maybe it's like a little one on a watch or something. It's only moving 1/3 of an inch to the right and 1/3 of an inch back, isn't it? It's barely moving, not 7 inches like a big grandfather clock or something. So this one's barely moving. That's what that 1/3 is, how far it's moving. What does the fact that it's sine instead of cosine mean about the real life movement of the pendulum?
Starting at 0.
Yeah, remember the only difference between sine and cosine on the graph is sine starts at 0. Oops. Does the same exact thing as cosine. Cosine just starts, this is sine. Cosine just does the same but starts high. Right? That's the only difference. Sine and cosine are the same. It's just different starting points, right? Is that real clear for you? So that means we're talking about the same exact kind of pendulum. This one is only moving 1/3 of an inch. And it starts at the bottom. We're just at time 0. We're just clocking this thing at time 0 starting at the bottom. The last one, we started on the right because cosine starts high. That's the only difference. It's just where you're starting the thing. So can you answer the 3 questions from there? So what is the maximum displacement? What's that going to be? Just a 1/3, right? Just a 1/3. Is that too easy of a question to answer? So 1/3. And then question B, what's the frequency? So how many cycles per second, in other words? How frequently is it completing a cycle? That's what they're asking. What's the frequency? How do we do frequency? It's upside down of period, right? So it's so 2 pi over b, it's b over 2 pi. So the b, what's the b?
2.
Yeah, got the a here and the b there. So the b is 2 over 2 pi. The 2's cancel. It's 1 over pi. And just enter the answer just like that, 1 over pi. And finally, what's the period? Their third question is time for one cycle. That's fancy talk for period. What's period? Just grab this and flip it. Upside down, pi. Done. Good? Easy questions? Real life pendulums and many other things moving back and forth, back and forth, back and forth. All right, you got that down. I'm going to move on. This will be on the YouTube later. I'm moving a little fast. Whoops. Wrong one. I did it again. Let me try one more time. There, it's almost invisible. Okay, there it is, number 8. Question number 8. Got to find x there. A couple angles. We have 500. That one part down here is, this part's 500. You all seeing that okay? So that's 500. How can we find that x? Okay, yeah, so control. Go ahead. Let me let you give it a try. You can get more out of it if you try first. Get that x. How y'all doing? Do you see that part of the problem is we can't do the whole x at first. We have to like call this y, just this part, and call this z, just this part, and find each one of those separately and then add them up. Do you see that? Because it's two different triangles. See the problem there? It's two different. X is actually part of two triangles, so we can't get it directly. Got to get y, then z, or whatever you want to call them, a and b, and then add them up. So let's just try to find y now. How would you find just y? So just look at that top triangle only. 37 degrees, 500 here. Find y. Right? Just look at that top triangle. How would you find y? What trig relationship involves 37 degrees, the y, and the 500? Sine, cosine, or tangent?
Tangent.
Remember SOHCAHTOA? SOHCAHTOA, yeah. This is opposite over adjacent, isn't it? Tangent. You good there? So that means tangent of 37 degrees is opposite y over adjacent 500. So that will allow us to solve for y. Everybody seeing that? I'm grabbing, it's two triangles, isn't it? I'm just going to do each one. It's like two problems in one. Two triangles. Find the right side of them. And so down here now, I'll do the bottom triangle. And I'll say, okay, this one, call it z or whatever you want. This is 27 degrees. This is the 500. So there's the bottom triangle. Everybody see that? And now what trig relationship involves the 27 degrees, the z, and the 500? It's tangent again, isn't it? Because this is the opposite. This is the opposite. And this is the adjacent from the 27. So this will be tangent of 27 degrees is opposite z over adjacent 500. Everybody see those two trig relationships I've obtained? So how do we, so let's solve for the letter in both cases. So solve it. How do you solve for y in the top one?
Multiply.
It's always the denominator, huh? Whatever's in the denominator we multiply by. So multiply by the 500. Cancels it out. So 500 tangent 37 is y. What? I'm just going to leave it like that for a minute rather than get a decimal. Let me just hold off for just a second. I think it'll be a little easier. It doesn't matter really. Second one, 500 on both sides, same thing. Boom. So 500 tangent 27 is z. So I got z, I got y. Now I just add them together. So the answer then, x, in other words, right? Because x is y plus z, isn't it? So it's going to be 500 tangent 37 plus 500 tangent 27. So let's get that. Make sure you're in degree mode. Always be checking your mode. You don't want to get wrong answers on next week's test because you're in the wrong mode. So practice with your homework, with the practice exam, you know, to make sure you're aware of rating mode, degree mode, back and forth. It'd be a bummer to miss something just for that silly of a reason. But it will happen for sure. Don't let it happen to you. All right, so I'm getting 631 point, I don't know how many places. Oh, whole number. 631.5, so that'll round to 632. You want a whole number? Y'all getting that okay? 632? Questions on that one? That good? Take it in two parts, two triangles. All right. There we go. Try that one. Number 9. Give you a minute. I want to find x. We're going for x. Well, yeah. Let me jump in right in the beginning and help you. So you draw that one on your paper there. Give you a second to that. And as you do, let me call your attention to the fact that all the SOHCAHTOA stuff we're doing, all the SOHCAHTOA, the sine, cosine, tangent, all of it is only for a right triangle. I don't know if you've noticed that it's just easy when you're so busy doing all these calculations all the time, just to kind of miss the forest for the trees. I did as a student. I would just get so into the little stuff, I'd forget kind of the big picture. Remember, the big picture, all of this is only in a right triangle. So notice, if I was to give you some kind of triangle like that, well, I know that kind of looks like it does have a right angle up there. I'm trying to draw one that doesn't have a right angle. Maybe one like that. Yeah. You can't do these trig things in that. Like if I said, hey, this is 30 degrees, this is 7, find this x. You can't go, oh, okay, I'll do sine because it's opposite over hypotenuse. That's not the hypotenuse. This is not 90 degrees here. So I don't know if it hits you. Let me just say it really clearly. This stuff, the SOHCAHTOA, they all have a hypotenuse. Well, even the tangent one has to be in a right triangle. They have to be in a right triangle. Hypotenuse means across from the right angle. These only work in a right triangle. Okay, so why I'm making a big deal out of this? Look at this triangle on the right here. Is that a right triangle? No. So we cannot go directly for that triangle. He's going to have to be secondary. We'll do something else first. You with me? I know that I can't just dive right in here and go, okay, here we go. 34, sine, cosine, tangent. No, he's not a right triangle. He's not a right triangle. Not a right triangle, is he? So don't start with him. He can't help us. Not at first. He'll be secondary. Well, then what is? Here's a right triangle, huh? That's where we're going to start. See how I know to do that? Because that's a right triangle. Right? You guys tracking with me? It's making sense. I want to show you how you want to think about these. This is a right triangle. So you go, oh, I got to start there. Call this y. Call this little part right here y. And find that first. That's what you have to do. So first find that y, and then I'll help you from there. So first, can you get that y? That's why these are hard problems, because they're two-steppers. The answer is indirectly found, just like the last one. These are hard. These take practice. They won't come to the casual. So try that one. What trig relationship involves 68 degrees, 200, and y? What trig relationship is that? Thinking about SOHCAHTOA. From the 68-degree perspective, from that angle's perspective, the 200 is across from it. It's opposite. The y is adjacent, and this would be the hypotenuse. So that's opposite over adjacent. It's tangent again. Seems like it's always tangent, huh? Tangent, 68 degrees is 200 over y. Everybody seeing that so far? See how the 200 is opposite from the 68 degrees? Tangent of 68 is 200 over y. So now we can solve that for y. Let's do that. How do you solve that little equation for y?
Multiply by y.
Whatever's in the denominator, be it a number or a letter, whatever's under the bar, we multiply by, don't we? So multiply, yeah.
Can you just find out the...
Chanu?
Yeah.
Yes, all right.
Find out the top angle and just do tangent.
Yeah, that would work too. Good idea. Yeah, the other way is you could just find out that top angle by subtracting from 180, or you could just subtract 68 from 90. That's probably I keep saying from 180, but really, you've already got a 90. So that leaves 90 left for the other two angles. You can just subtract from 90 to get that one. That'd work the same. Yeah, that'd work fine too. So I'm going to multiply by y. So I'm just going to do it my way, but that way would work fine. Multiply both sides by y, cancels out, and I get y tan 68 degrees is 200. Last step, divide by the tan of 68. Boom. So we got y, right? Y is 200 over tan 68. So let's get that in a calculator. So y is 200 over... Make sure you're in radian mode. I'm sorry, degree mode. Now, here's what you want to do, guys. They want a whole number in the end, but I'm not at the end yet. So use a lot more. When you have a number that you're going to use for further calculation, you're not at the end yet, use a bunch of accuracy. Use more than you need in the end. 8.8052. That's plenty. 4 decimals. Does that make sense? Use more accuracy than you're going to need in the end. In the end, they just want a whole number. So this is way more accurate than I need. But I'm going to use this for a further calculation. So now I know why. I know this right here. Okay, now, are everybody with me? I'm about to take another step. That's half the problem right there. Everybody good so far? Now that I have y, in fact, let me just go over here and write it. Get rid of all this stuff for a minute. Y, this right here is 80.8052 right here. Now that I have that piece of the puzzle, now I can look at the triangle as a whole, like this. Now, why? Why am I going to look at the triangle as a whole? Why aren't I looking? Isn't it time to do the right side now? No, I'm never going to do the right side alone because the right side is not a right triangle. I'm never going to do the right side alone. There are 3 triangles up here. Does everybody see it? Left one, right one, whole one. 3 triangles. 2 of them are right triangles. The left one is a right triangle. The whole one is a right triangle. But the right one is not a right triangle, so I'm never going to use it. Does that make sense? I'm going to use the left and I'm going to use the whole because they're both right triangles. So they'll work for my SOHCAHTOA stuff. All right, so now do the whole triangle and use the 34 degrees. How does 34 relate to the 200 and this, which is x plus 80.8052? Tangent again, right? The tangent of 34 degrees, 34, getting kind of sloppy, is opposite 200 over 80.8052 plus x. Everybody see that? Little fancy work here. The tangent of 34 is opposite over adjacent. It's 200 over 80.8052 plus x. That bottom is 80.8052 plus x. That's why I had to find that first. These are not simple problems, are they? Okay, so now can we solve for x? Yeah. What do we always do when we got a fraction? Whatever's in the denominator, whatever's in the denominator. Simple number, simple letter, or a big mess. You multiply by it, huh? So let's do that. So I'm going to multiply both sides by that whole denominator, which is 80.8052 plus x on one side and the other. 80.8052 plus x. Cancels here. So we always do, right? Denominator, multiply both sides. That gets rid of it on one side. What do we have on the other? 80.8052 plus x tan 34 equals 200. You with me so far? This one's not an easy problem. That's a very funny math class there. All right, now we distribute like that. Right, whenever you have something next to parentheses, you distribute. So I get 80.8052 tan 34 plus x tan 34 is 200. This thing's a mess, isn't it? You guys with me? So I just distributed. I just took that whole tan 34. Right, anything next to parentheses just distributes, doesn't it? I just distributed. Is that good so far? Am I losing you? Yeah.
Can you do the same thing you did for the 68 angle for 34?
Say it one more time.
Can you do the same like the tangent over like 34 over 200, like 200 over tangent 34, and get the same?
Yes, so instead of doing what you did, just divide tangent 34 for both sides. Instead of like,
Oh, yeah. Oh, that would be easier. Oh, yeah. Good job, guys. Yeah. That's a good idea.
that you just.
That's right.
80.
I was testing you to see if you would notice that. Good job. All right, yeah, I like that idea. Let's do that. Is a little bit better than doing that all that distribution stuff. Nice. Divide by tangent 34. Boom, that'll be a little easier, a little cleaner, huh? All right, so 80.8052 plus x, and then just, yeah, whatever your calculator says on that other side. 200 divided by tan 34. I'm getting 296 point, and I'm going to use 4 places again. Just, use more accuracy than you need. 5122, and then yeah, that's nicer, huh? And then just subtract the 80.8052, and we're there. Good. Good work. So subtract that 80.8052, 80.8052 from both sides, and whatever that is, minus 80.8052. And I'm getting 215.7. They want me to round whole number. 216. There we go. That was a rough one. So I'd always have to redo problems like that 2 or 3 times on my own, to master them before the test. So I would just look at that again, go over the YouTube again or whatever. When I get to the homework problem, I guess it's in the homework, just make sure I could do it, top to bottom. Questions on that one? That was a tough one. So remember, it's all about right triangles, huh? There's 3 triangles up there: left triangle, right triangle, whole triangle. 2 of them are right triangles, the left triangle and the whole triangle. So those are the 2 we use. All right, we're getting fancy in trigonometry. This will be easier, but it's all words, so it can be a little tricky. So, television transmitting tower in the world is in North Dakota. I didn't know that. Tallest television transmitting tower in the world. Okay, from a point on level ground, 5,280 feet, which is 1 mile, from the base of the tower, the angle of elevation is 25.8 degrees. Find the height of the tower. Okay, let me draw a picture for you. So we have this tower, and we have this angle of elevation, 25.8 degrees, and this is 5,280 feet away from the tower. How tall is the tower? That's what they're basically saying. Angle of elevation, whenever they talk about an angle of elevation, they mean from flat, from horizontal up. That's what they mean. So from flat, how far do you elevate? See how this is from flat up to what angle? 25.8. So that's what they mean by angle of elevation. They use that word a lot. Pre-calc, calc, all kinds of problems. We'll talk about angle of elevation. That means from flat, how far has it been elevated? So it's elevated 25.8 degrees. So, and this is a right angle, assuming that's not the leaning tower of Pisa. It's a straight up and down tower. Goes straight up like that. So we have a right triangle. So we can do our SOHCAHTOA stuff. So can you find the height of the tower there? Give that a try. One of your SOHCAHTOA relationships. So you can call this side X or whatever you want, That's what you're trying to find, right? Height of the tower. We good? So what trig relationship involves the 25.8, the x, and the 5280? Tangent again. It seems like it's always tangent. I don't know why. It's tangent again. So the tangent of 25.8 degrees is x over 5280. Opposite over, right? This is opposite over adjacent, huh? Good like that? So how do we solve for the x? Denominator. You multiply by the denominator. Both sides every time. He's getting easy now. This one's easier. If you can get those words into a picture. 5280 on both sides cancels out, so I get 5280 times tangent 25.8 degrees is X. Hit the buttons on your calculator. Tangent of 25.8. Make sure you're in degree mode. I'm getting 2552.4. What do they want? Nearest foot. So we'll say 2552. 2,552 feet tall tower. Is that good? Is that making sense? So there's actually instruments that they use. Well, now it's all lasers and stuff. But in the olden days, they would use something called a sextant, which you could look through and you look up at the top like of a tower or whatever. Right? You'd stand a certain, you would know, okay, I'm exactly 1 mile. That's 5,280 feet is 1 mile, as they said. So I'm 1 mile from the tower, and then I use this thing called a sextant. It's like it had a little, you would look through this hole towards the top. So you'd put it right here, and your eyeball would look through it to where you see the top of the tower, and it would have a horizontal piece, and so you would know the angle. Then you would look at it, it would tell you the angle that you're seeing. You'd hold this part flat, and then you'd look up, you'd move it till you saw the top of the tower, then you'd look at the angle. Now it's all lasers, I'm sure. But that's how, so you would know the angle is 25.8 degrees. That's how they would do that. So they'd say, I'm a mile from the tower, I got my sextant flat, turn up till I see, boom, I'm at the top of the thing. What's my angle? They do their little calculation. They know how tall that tower is. They don't have to climb it. They don't have to do some fancy thing, run a rope down it, or however else they would figure out, or for a mountain, or for anything. They can figure out the height of an object, how high that plane is. If you know how far you are horizontally from it and the angle up, you can calculate height of object. I was asked that question a few years ago, randomly on the phone one day. It's kind of funny. It was summer school. It was probably 7 years ago or 6 years ago. I got back to my office after teaching summer school in the afternoon, and I had a message on my phone. I played the message, and the message said, yeah, hi, Brett. He used my first name. Hi, Brett. This is Hank. I can't remember what the name was. Hank or something. I'm out here at a job site, and I need to order. I've got a couple of trees I got to take down, and I can't tell if the tree is. There's two different backhoes that I could order. The big side, the medium or the large. The medium is for taking down trees that are under 100 feet, and the large is for trees that are over 100 feet. I can't tell if the tree's over 100 feet or under 100 feet. I only said something like 100 yards from the tree, and I'm measuring the angle with my sextant. It's at 25 degrees. Could you tell me if that tree's under 100 feet tall or over 100 feet tall? I heard that message, and I'm like, Hank, or whatever the name was. Hank. I don't remember Hank. It's weird. So I just called back, and and he picked up the phone right. Hello, this is Hank. And I'm like, hi, Hank. Yeah, this is Brett Heron, Fresno City College. Oh yeah, Brett. Oh yeah, my first name again. Yeah, it's like he knows me. So I thought he did. So it's like, yeah, Brett, I'm out here. He starts writing to his spiel. I'm at the job site. I don't need to. Oh yeah, hold on, Hank. Just 1 second. I'm sorry. I said, I'm sorry. I just don't remember where I know you from. He's like, oh, you don't know me? You don't know me? I did. And I'm like, oh, how'd you get? He's like, oh, I needed a math question answered, so I thought I'll just call the community college, and they put me through to the math department. I'm like, okay. So I just figured out the problem for him and said, yeah, here you go. And anyway, it was funny. And he's like, oh, yeah, I remember that trig stuff. It's just been too long. I couldn't remember which angle. Anyway, so you never know. You might get a call. All right, so there's my funny experience. Guess we are the community college. We're there to serve the community, so even random math questions. All right, so try that one. So what I would do is you need to get one of the angles inside the triangle, don't you? You don't want that 36 degrees. Trying to find out the distance D. You're here at point P, and you're trying to find out how far apart are these two islands. And you're doing it by noticing the chopper is 950 feet high, and you want to try to calculate the distance between the two islands. So you basically have to turn that 36 degrees into some angle inside the triangle, don't you? So can you figure out this angle here? What are we going to do?
Well, it's a perpendicular, so
Yeah.
it's
90 degrees.
90 degrees, exactly. So 90 minus 36 was that? 54, yeah, thanks. So this is 54 degrees. 54, all right, 54, D and 950. What trig relationship is that? Tangent again, isn't it? And when in doubt, do the tangent. Tangent 54 is d over 950. Tangent 54 is d over 950. So, you know how to do it, right? Just multiply by 950 and you got it. So multiply both sides by 950. So there we go. Off we go. Well, here, I'll calculate 950 times tangent. Whoops, I hit the wrong button. Tangent 54. That's 1307. They want it round. I don't know how far they want it rounded. I'll say 0.56. They probably just want 1308, huh? 1308. That's how many feet? Yeah, feet apart those two islands are. All right. So. So, all right, so you can see the question mark. They want us to find this, call it X or whatever you want to call it. That's what they want us to find. See how there's really, again, three triangles there? There's the small one, the big one. Well, there's three. There are three, right? There's the bottom one, the top one, and the whole one. Right? But only two of those three are right triangles. The whole thing is a right triangle, and the bottom one is a right triangle. So we're going to use the whole one and the bottom one, aren't we? So first, we're going to find this. Find y using the 19.9, which is the angle for the bottom triangle. So first find y. And then we'll find the entire height using the 33.8 for the whole triangle, and then subtract them, and the difference will be x, won't it? Does that make sense? Find the whole side, subtract the y, and you'll get x. That's the game plan. So it's tangent again. So tangent of 19.9 degrees is opposite y over, bless you, over 124. Is that good so far? So we can solve for y. Multiply both sides by 1. Or maybe I better bring it down a line. So multiply both sides by 124. Boom. And that's going to be times tangent of 19.9. I'm getting 40. I'm going to use a lot of accuracy because I'm still in the middle of the problem. So 44.8874. I'll round to 4 places. So there's y, rounded to 4 places, just lots of accuracy. Okay, that's y. Now I need to find the entire height. Say like the whole thing, call it, z if you want. The whole thing, top to bottom. Maybe it'd be best if I just redrew the triangle. The whole thing, call it z. And this is now 33.8 degrees, and this is still 124. So now find the whole z. That way, again, it's tangent. So I'm going to go tangent of 33.8 degrees is z, the whole thing, over 124. So you know the drill. Multiply both sides by 124. Cancels out. And I get 124. Tangent 33.8 degrees is z times tangent. And I'm getting 83.0108. And that's z. So we got z. We got y. Subtract them, right? Because all z is the whole thing. Subtract y, you'll get x, won't you? So that's our final calculation. X is z minus y. So come up here now. X is z minus y. X is z. 83.0108 minus y. 44.8874. And X is whatever that is. 83.0108 minus 44.8874. I'm getting X is 38.1234. I don't know what they want it rounded to. Probably just one spot, probably just 38. Is that good? Two triangles, subtract them? Questions I can answer on that one?
Did you have left? I did it different, but I got the wrong answer.
What we should
But I was
Dana?
wondering-
Dana? Yeah. Dana.
I was wondering if you could do it like you did in another previous problem where you, I don't know how to explain it.
Where you try to do the tangent.
Where you,
Tangent that's good. Is y. We're good. What's your y? Oh, I see. Tangent of the whole thing is x. Yeah, that's true.
and then could you have done it like this?
Totally. Yeah, that's totally right. And so 124 tangent. Oh, right here you gotta subtract that. That's added. That's your only mistake. Very last step. That's added. So just subtract this.
Oh, okay.
Right, because it's not divide there. Because it's not times that. Huh?
Right.
It was times we divide. Yeah, perfect. Yeah, there's other ways. Feel free to grab me after class. That was a perfect way. Good again. So we're going to put the bearing in the middle of like trig triangles now. All right. So the boat leaves an entrance to a harbor and travels 125 miles on a bearing. So 125 miles on a bearing that is north 55 degrees east. North 55 degrees east. How many miles north, how many miles east, blah, 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 blah. All right. So first thing, can you draw north 55 degrees east? Go ahead and draw. What do I mean draw? So I mean, like if you have a kind of a coordinate system. North 55 degrees east. So you first go north, right? So first go north, that's straight up, north. And then you go from north 55 degrees towards the east. So that would be about like here. Whereas that's 55. It's a little more than half because it's more than 45 is half, right? 45 is half of 90. But it's a little more than half to the right, to the east. So here's the heading of the ship. Right, the boat. The boat is here goes, this is the true direction of the boat. It's going north 55 degrees east. Sometimes you'll hear them say 55 degrees east of north. Either way, it's the same thing. Anyway, so north 55 degrees east. Okay, and it traveled how far? 125 miles. So that's the length of that piece is 125. The boat went that direction, 125 miles. Their question to us is how many miles east did it go? How many miles north did it go? Yeah, north and east. So in other words, they want this and this. Whoops, didn't do a very good right triangle there. They want to know how far east did it go? How far north did it go, huh? They want you to make a little right triangle there. Everybody see that? Right? Because the boat, this is the boat going 125 miles this direction. North 55 east. And they want to know how far east is that, right? How far to the right did the boat move? The boat went diagonal, but a diagonal movement involves some rightness and some upness, doesn't it? When you get into pre-calc and calc, that'll be called the components of a vector. You'll get into that. You'll do this exact same thing on physics all the time. They'll give you a vector, something that's headed diagonally, and they'll say find the components, find the horizontal and the vertical components of a vector. You get into physics, and they'll throw a ball or shoot a missile diagonally, and they'll say, how fast is it moving horizontally? How fast is it moving vertically? And you'll do all kinds of things with equations in two separate components on that, like that. So, good for the future practices. So if we have a triangle here, this is 125 on the diagonal. How far is this and how far is that? Just finding two sides of a triangle, basically. How far is the east? How far is the north? Well, first thing is we got to get this angle inside of our little triangle, don't we? So what's that angle got to be? Yeah, take from 90, huh? 90 minus the 55, going to be 35. So this one is 35 degrees. 35 degrees. So now we want 35 degrees and we want something involving north and 125. Hey, it's not tangent. Right? This angle, north, and one. Then I'll do east. Two separate equations, one for north, one for east. We'll do them separately. So to find the north component, like how far that ship moved northward with that diagonal movement, how far did that ship move northward? It's going to be, this is opposite, and this is hypotenuse, huh? So we're going to do opposite over hypotenuse. So that's sine, right? So katoa, opposite over hypotenuse. It's not cosine, so katoa here. So that's a funny looking A. So anyway, it's sine. So sine of 35 degrees will be, getting kind of scribbly there. Sine of 35 degrees will be opposite, will be the northern component over the 125, won't it? Right? Opposite over hypotenuse. You with me? That good? And then how do you solve for the northern component there? Multiply by the denominator yet again. Multiply by 125, boom. The northern component of that diagonal movement is 125 times sine of 35. I'm getting 71 point, how far they want it? Nearest tenth. So I'll say 71.7. I got 6.9, just round to 7. 71.7 miles north. And now let's find the eastern component. To find the eastern component. So what, getting back to the 35, eastern over hypotenuse? What's going to involve the eastern, which is the adjacent side over the hypotenuse? That's cosine. So cosine of 35 degrees is the eastern component over the 125, right? Adjacent over hypotenuse, cosine. And then solve that one. Same thing, multiply by 125, the denominator, and get east equals 125 times cos of 35. Get 102.4, 39 rounds to 4. So there we go. So this is 102.4. The northern component was 71.7. That means when that boat goes diagonally, north 55 degrees east, that diagonal movement, 125 miles, it actually moved 102.4 miles east. It moved 71.9 miles north. We broke a diagonal movement into horizontal and vertical components, like that. Is that good? Does that make sense? Questions on that? Question? You good? Everybody happy? Let's see. So a forest ranger sights a fire directly to the south. Second ranger, 6 miles east of the first. Okay, let's start drawing this out. So we have a ranger, and he sights a fire directly. So here's the ranger, here's the fire. Directly south of him, it says. So that's directly south. Directly south. The second ranger is 6 miles east of the first ranger. So here's ranger number 2. Directly is ranger number 1. 6 miles to the east. Good? I'm just following the words and mapping them out. So first ranger sees a fire directly south. Doesn't say how far though. Second ranger is 6 miles east to the right of the first ranger. Here's ranger number 2. Also sights the fire. The bearing from the second ranger to the fire, this bearing here, is what? South 27 degrees west. They're telling me that's south 27 degrees west. So it's south, but 27 degrees west of south. They're telling me the bearing of this second ranger to the fire. You with me? We're going to kind of triangulate where the fire is by two rangers. This is like triangulation. Two rangers sight the fire. And so with that information, we should be able to figure out their question. How far is the first ranger, ranger number 1, from the fire? What's this, in other words? Right? Because here's the fire. Here's ranger number 1. What's the distance? So we should be able to figure out that x from that information. Is that good? See how I tracked that? All right. We have a right angle right here. So we need an angle inside of our triangle. So you know what to do. Subtract from 90, right? 27 minus 90, what's that? 63. 62 degrees right there. Drawing that picture, though, that I just drew is a lot of the battle which you need to practice on your own. So, so when you go back over this, try that part on your own. I would watch my teachers do this kind of stuff, and probably seems right to you. It always seemed right to me. And then I'd go home and try it on my own. I'd go, what did that teacher do again? How did that picture? And so that's where you got to practice. You got to try that on your own. I'm kind of prompting you through it right now. It's not the same as doing it on your own. So, okay. So, therefore, we got that. So, what trig relationship involves the 63, the x, and the 6? Back to tangent again, right? Because that's the opposite. That's the adjacent from the 63. So, back to tangent we go. Oops. Tangent 63 degrees is x over 6. Opposite over adjacent. Solve for x. Multiply both sides by the denominator as usual. So x equals whatever 6 tangent 63 is. And I'm getting 11.776. How far are they? Nearest 10th. So 11.8. That ranger must be 11.8 miles from the fire. Good on that. That's how two sightings can locate something. How we do? Okay, so you leave your house. So here's your house, let's say. You leave your house and you run 3 miles west. That's why I'm going left. 3 miles west. And then 1.5 miles north. What's your bearing? Well, okay. So now let's make a triangle out of this. Let's make ourselves a triangle. Right angle here. Right, I want west and north. Good so far? Now the bearing is always off the vertical. So technically, the bearing is going to be this angle, isn't it? It's going to be north something west, isn't it? I can see it already, right? Everybody with me? Because we went left, west, and north, which means we headed diagonally that way, upper left, didn't we? Remember, bearings are the opposite of reference angles. They always come off the vertical. So really, I need this angle. But first, let me do the triangle work, get the angle in here, and then I'll subtract from 90 to get my bearing angle. Question?
Can't you find the angle that's from the north and do the alternate interior angle?
Find this angle right here, and then this is alternate interior. Good geometry. Yes, that's right. These will be equal, won't they? Because they're alternate interior angles. Yeah, exactly. That'll work fine. Yeah. All right. I'm probably not going to do that because I don't think most remember all that geometry. So I'm just going to do this one right here. So I'll just do this one first, but you can do either one. That's exactly right. So let me find this angle here. Call this theta, or whatever you want to call it. I need to find that angle. And then I'll subtract from 9 to get my bearing angle. So how do I find that angle? What trig relationship?
Tangent.
Here we go again. So tangent of that angle is opposite over adjacent, huh? 1.5 over 3. Okay, good to there so far? That okay so far? Now, what's weird looking? How do I find the theta angle inside of a tangent like that? What do I do? It's inverse. Do y'all realize that? That means, how do you get an angle? How do you solve for an angle inside of a trig function? You got to do the inverse. That's the inverse question. Theta will be inverse tangent of 1.5 over 3. Does everybody see that? Whenever you need to find the angle, to find an angle, use inverse, whatever, sine, cosine, tangent, whatever. Maybe that's the best way I could write it for you. To find an angle, whenever you're looking for an angle, that means you got to do inverse, right? Why? Because the inverse of an answer equals an angle. Remember, inverse function switch? So you put in an answer, you get out an angle. So that's why. So whenever you're asking to find an angle, you got to do the inverse. So there it is. Hit the buttons on your calculator. Tangent inverse. That's just a half. You just type it in 1.5 over 3, same thing. So the angle is coming out for me 26.5651 degrees. I don't know how much actually to use. That's the angle theta here. That's this angle. I'll just say 26, well, I'll write the whole thing, 0.5651 degrees. So then the bearing, to find the bearing, I subtract from 90. The bearing will be 90 degrees minus 26.5651. What's that? 63.4349. Right there, when you subtract, that's the bearing angle. That's this one. 63, I'll just say 63.4 degrees. It's the bearing angle. So what's my final answer then? And what the bearing involves north, south, east, and west and stuff also. So it's the bearing is always off the vertical, isn't it? So how would you say the bearing? Which way is this? Are we headed if we run left, west and north? What's our actual bearing in the end?
North 63.
North
63 west.
63.4 west. Because you're going north. You're mainly, remember, you always say the north or south first. You're mainly going north. You're going north 63.4 degrees west. Because you go west of north. There it is. Is that good on that? Questions I can